Hello dear students, we are going to solve this sum from equilibrium chapter. So this sum says that the table below gives information about the percentage yield of ammonia obtained in Haber process under different conditions. So they have given this pressure in atmosphere and temperature. So whenever this type of sums are there, what you have to do is you have to identify. This is the first part of the question, A part. From the table, identify which combination of temperature and pressure gives the highest yield of ammonia. So here these are all yields. These they have given yields, and this is the temperature what they have given, and this is the pressure here. So pressure is given here. So first of all, let's see wherever the highest value is there in out of all this. Now you have to find out which is the highest value. So here we can see 50.7, 80, 81.7, 89, 89.9, 94.6, 95.4. Here is actually this side it is maximum is 84.2 and this side it is 65.2, and at 500 it is maximum is 42.3. So you can see here at 6, it means this is the highest value 95 in whole of this section, all this section. So 95.4 is the highest value. That means at a pressure of 600, this pressure atmosphere, and temperature here, temperature is 200 degrees centigrade. So at the pressure of 600 atmosphere and at 200 degrees centigrade, so we have to write like this: pressure of 600 atmosphere and temperature of 200 degrees centigrade. Yield equals to how much? Yield is 95.4, which is maximum. 95.4, which is maximum. So in this way we can solve this first part. So the B part of the question says that the equation for the main reaction of Haber process is, they have given this equation: N2 plus 3H2 will give 2NH3. So ammonia is formed and delta H is negative. So they have asked the first point, what happens if the pressure is increased? So if pressure increases, increasing the pressure, so what will happen? So always remember here, the main point is that you have to count the number of molecules on both the side. So here we will count the molecules. So on the right side where product side is there, so you can see here 2NH3, okay, and here 3 plus 1, 4, 3 hydrogen is there, okay, 3 hydrogen and 1 nitrogen, okay, so this is 1 nitrogen. So here 4 are there, so 4, and this side only 2, so here 4 and 2. So as you can see here, increasing the pressure actually favors the least molecule side, which one is having least. So out of 4 and 2 is the least. So that means increasing the pressure will actually increase the ammonia production, because least molecules are on this side. So this is the important thing. So increasing the pressure will yield more ammonia, so that you remember. So this is the way how you can solve. You have to just count the molecules. Wherever the least molecules are there, that side the equilibrium will shift, and that side here the molecules are toward lesser, a molecule is towards the ammonia, because 2 molecules of ammonia are there. So that's why it shifted towards the right side, that is towards the product side. So that's why it will yield more ammonia. So now let's talk about what will happen if we increase the temperature. So let's see, if temperature is increased, what happens? So always remember, you have to see this value, delta H value. So here delta H value is negative here. So always remember, delta H negative means what? This system is already having heat inside this, and if you supply more heat, then what will happen? The product form will be less. If delta H is positive, then it needs heat, because it is endothermic reaction. In endothermic reaction it needs, but here delta H is negative, it is exothermic reaction. Whenever exothermic reaction is there, that means if you are increasing the heat, and already it is having heat, because delta H is negative, in the system lots of heat is there and you are supplying heat, so it will be useless. What will happen? The equilibrium will shift towards the left side, that means product form will be less. So that's why you should remember in this way. So that's why you should remember, as the reaction is exothermic, increasing the temperature causes the equilibrium to shift towards the left side, that is towards the reactant side. So whenever reactant will be formed, that means product will be less. So that's why ammonia form will be decreased, and N2 and H2 will be formed instead. So that's why this is the main thing you should remember. Yield lesser ammonia. Now let's see the next part of the question, which is C part. Here they have asked one thing. In practice, typical condition used in Haber process are temperature of 500 degrees centigrade and pressure of 200 atmosphere. Now, explain why these conditions are used rather than those that gives highest yield. We saw that highest yield we were getting at how much? At 600 atmosphere, okay, and at 200 degrees centigrade, and this highest yield was this one, 95.4. Instead of 600 atmosphere pressure, we are using 200 atmosphere. Why? And here 500 degrees centigrade. Instead of this, instead of 200 degrees centigrade, we are using 500 degrees centigrade. So why so much, actually why there is so much increase in the temperature and why there is so much decrease in the pressure? The main thing is that you should remember temperature can be increased. There are vessels which can actually withstand the higher temperature also. But no, it is very difficult to make vessels or equipments which can withstand such a high pressure of 600 atmosphere. So that's why because of this problem, that's why it is very difficult to manufacture such type of equipment, because lots of metal is needed to make a thick jacket so it can withstand lots of pressure, so of around 600 atmosphere. That's why it will be very costly to manufacture such things. So that's why it is not actually advisable and it is not economical to use this one, okay, at a higher pressure and at temperature of 200 degrees centigrade. Instead we are using a higher temperature, that is 500 degrees centigrade, and pressure of 200 atmosphere. So let's see the next part of the question. Here the next question is write the equilibrium constant here. So equilibrium constant, you have to actually write the equilibrium constant here, expression for this production of ammonia. So for this we have to just see the values of whatever they have given in the equation. So we will write here. So equilibrium constant is given by Kc, okay. So equilibrium constant expression Kc equals to, so you have to write the product in the numerator. So this is the product is ammonia. So write here in the numerator NH3, and then this coefficient is there, you have to write in a squared bracket, and this coefficient, before this you can see 2 is written here. So whenever 2 is written here, so this 2 will become indice here, this 2 is there, so this 2 will move here and it will become indice of this. So it will become indice of this one, so it will come here like this, 2 raised to 2. Now upon, so here this will be 2, I will write in red color. So now product in the denominator we will write the now product we have written in the numerator. Now whatever the reactants are there, that we will write in the denominator. So N2 and S2. So here you can see N2, so N2 we will write here in the denominator in a square bracket, this N2 we have written, and then now we it is the, now we have to write this H2. So H2 we will write here, but the thing is that before H2 here 3 is also written, so this 3 will become indice of H2, so it will become like this. So this is how you have to write this equilibrium constant expression. So in this way you can solve other questions also related to this type of equation if they have given. So thanks for watching my video. Take care. Bye.